Welcome back, everyone. Today is the fifth lecture. So, we're learning about detection of functional groups in organic compounds. And let me tell you, practical chemistry has never been so much more important because it was asked in NEET 2026. There were so many questions. And it's good that if you still remember what you've done in your practicals, but if not, in these 20 days, we are definitely learning this. So, let's go with the first thing. So, I'm just thinking if we could do it like a mind map because there is alcohol, test for phenols, test for aldehyde and ketonic group, and we do have test for carboxylic acid and amino group. So we have like five things, and I thought if I could make it like a beautiful mind map kind of a thing, it'll be much nice. Oh, so bad at putting straight lines. Sorry. Okay, I'm just gonna make a huge horizontal plane so that we can like scroll through and revise there. Okay. So what is the first thing? So first we have alcoholic group. Give it to an alcoholic person. Okay, I'm sure there's no kids doing alcohol, but I'm just making you guys understand it better. Okay, don't come at me. Okay, right. So in alcoholic we have three tests. We have CAN, Lucas, iodoform. Let me put that down. We have CAN, basically ceric ammonium nitrate, and we have Lucas test and iodoform test. Alright, so these three are basically the test for alcohols. So let's see what is the ceric ammonium test all about. Important, they're gonna ask you how is the complex like. Okay, I'll come back to it, but let me just tell you the most basic thing, which is alcoholic compounds on reaction with ceric ammonium nitrate gives a red color due to the formation of a complex. So you need to remember what is ceric ammonium nitrate. It's basically ammonium, cerium and NO2 six times. Alright. Remember the complex they're gonna ask you. Just remember ceric ammonium nitrate, okay? Just see how it looks like, okay? NH4 is twice, Ce and NO3 is six times. Just have to know that. And let's say you're adding an alcohol. It's gonna give you another complex which is cerium four times, ROH thrice, and NH4, and it was the subproduct. The most important thing, you're gonna get a red color. So that is how the test is done. Red color. Okay, this is ceric ammonium nitrate test. Let's talk about Lucas test. For Lucas test, important to remember is the Lucas reagent. I'm sure all of you remember the Lucas reagent, which is ZnCl2 plus concentrated HCl. Okay, so you'll have primary, secondary, tertiary alcohol. Primary, secondary, tertiary. I think you know this. Tertiary gives immediate. So after, within minutes, I'll be right. And this is like no reaction. Alright, so this is how it is for the Lucas test. Very simple. So this reagent converts alcohols into corresponding alkyl chlorides. Zinc chloride, which is a Lewis acid, and increases the reactivity of alcohols with HCl. So let's remember that this is a Lewis acid. So what really happens here is ROH will get converted to RCl. And there was a question I was seeing like recently. They've given a cyclic four-ringed compound, and then there is a Lucas reagent test. And if there is ring strain and expansion, that is also allowed because you somehow need to form the stable carbocation. So that is also there. So remember that. Okay, moving on to iodoform reagent. Basically, let me just put this a bit sideways. Yeah, so the reagent is compound heated with I2 plus Ne2CO3, or you can write it as I2 plus NaOH, or you can write it as NaOI, or you can write it as NaIO3. They can give you any of these, okay? They can give you any of these and you'll have to remember it. And you'll have to know that this is an iodoform reaction and that is the iodoform reagent, okay? I2 and Na2CO3, I2 and NaOH, NaOI, NaIO3, okay? Now let's look into who gives the test. This is the most important. Anything that's like with this group or something like this, these can give the test. And let's also put a small reaction here. Like let's say I'm putting down, so when I add, let's say I put potassium hypoiodate, so I'm gonna first convert that into this, and when you put NaOH, you're gonna have I3, which is the iodoform, and HCOONA, basically an yellow iodoform, and you'll have an acid formed with it. Remember that. Simple, easy, good. These are very important, all these three. Okay, moving on to the next group which we're going to learn about, that is phenolic group. So with respect to phenolic, there are two reactions. You have ferric chloride test and you have phthalene dye test. Both are also awesome. Okay. Ferric chloride test is basically when phenols form violet colored complex with freshly prepared FeCl3 solution. Okay. So let's say I take alcohol or phenol and freshly prepped FeCl3. It's going to give me a complex okay, and this is violet colored. Can I use it for violet color? I don't know. I'm gonna use this. Okay, anyway, the same thing up here. Let me try lavender. Okay, violet color complex. And the subproducts are just these. Let's see who gives. And also, guys, important to remember is this FeCl3 has to be freshly prepped first off, and it has to be neutral, and it has to be very dilute. Alright, next there's So resorcinol, do you know what resorcinol is? It's this, okay? Ortho, meta, and paracresol. Do you know what cresols are? It's this. So they have CH there in the lecture or an ortho, meta, and para position. So they give violet or blue color. And catechol gives green color. And 1 and 2 naphthol, they don't give any, okay? Some small table that you have to remember. Okay, cool. Done with this test. Next, let's move on to phthalate dye test. Phenols condense with phthalic anhydride in the presence of concentrated H2SO4, and phenol condenses to give phenolphthalein, which gives a dark pink color with NaOH solution, and this is called phthalate dye test. It's simple. The actual structures are pretty hard, so I'm just gonna write it down. So the first thing we have is, let's take a phenol, and I'm gonna take phthalic anhydride. Let me just show you what phthalic anhydride is because it's there in the organic part too. And gabriel phthalimide, if you've seen. So this is basically a normal phthalic anhydride. So when you do this, you get in the presence of concentrated H2SO4, remember. So you get phenolphthalein, and this phenolphthalein is basically a dark pink color. With NaOH. This is the whole test. Just it's so simple. But if you put excess NaOH, it becomes colorless. Some simple things to remember. And if you're still wondering how exactly phenolphthalein looks like, it will have 3 benzene rings. Remember that. Okay. Right. So I think this is so much for our phenolphthalein. Next, let's move on to the next important test that we have, which is aldehydic and ketonic groups. So there's a huge thing for aldehydic and ketonic. So we have 2,4-DNP, and we have Felling's test, we have Skiff's test, we have Tollens test. So let's start with 2,4-DNP. What is DNP? Dinitrophenylhydrazine. So 2,4-DNP stands for dinitrophenylhydrazine. So let's see what this test is all about. So this test, which is performed both on aldehydes and ketones, they react with aldehydes to give 2,4-DNP hydrozones. So the color would be either yellow, red for aldehydes and ketones respectively. So if it's yellow, then it means you have aldehydes formed, and if it's red, that means you have ketones. And I've done this particular experiment in my chemistry lab, so it is pretty easy because you can easily distinguish whether you are having an aldehyde or a ketone when you sample. So yellow it's for aldehydes, red it's for ketones. So if I have to write in a very simple way, 2,4-DNP and then you add aldehyde or ketone, you're going to get 2,4-dinitrophenyl hydrazones, and then you're going to easily find if it's yellow it's an aldehyde, and if it's red it's a ketone. Okay, let's move on to the next reaction, which is where you're going to distinguish aldehyde as well as ketones. So three tests you have is Felling's test, Skiff's test and Tollens test. So let's start with Felling's test. Okay. The most important thing you'll have to remember with respect to Felling's test is who gives the test and what is the reagent. Because reagent for Felling's and Benedict's test can easily be confused. So it's very important to remember, and also remember that there is two solutions. There is solution A as well as B. So they might ask you which is A, which is B, and either it is aqueous copper sulfate or alkaline copper sulfate. So that is something you'll have to remember. So Felling's reagent is a mixture of freshly prepared Felling solution A as well as Felling solution B. A solution is basically aqueous solution of copper sulfate, and B is basically alkaline solution of sodium potassium tartrate. So sodium potassium tartrate is basically famously called Rochelle's salt. Okay, so remember which is aqueous, remember which is alkaline. So just keep doing this. I'll just be back in like 2 minutes. I'll be very fast. Okay, so let's continue. So we have solution A, solution B, solution A with aqueous solution of copper sulfate, solution B with alkaline solution of sodium and potassium tartrate, which is also known as Rochelle's salt. So let's see who gives this test. Carbonyl compounds which take part in 2,4-DNP. Okay, wait. We mix two solutions just before, as Felling reagent is not stable while separately. And Felling reagent contains complex of copper with tartrate ions as follows. So what you're going to have is with aldehyde and Cu2 plus, which is present in the solution complex, and OH minus is going to give you RCO minus, which is basically carboxylic acid. You're going to get Cu2O and H2O. So how are you going to identify the test is from the brick red PPT that you have. The brick red PPT is because of Cu2O which is present, that you'll get after the reaction is completed and after the formation of carboxylic acid. So let me write the reaction. So you'll have RCHO 2 plus and 5OH minus. Then you're gonna get RCOO minus plus Cu2O plus 3H2O. And this Cu2O is basically a brick red color. I think I can put this brick red PPT. Okay, so now let's see who gives these tests. And this is actually a wide thing because it's also present in aldehydes chapter. So let me just quickly check through the internet so that we don't miss any. So let me quickly find it out before I give to you. Could you give me a full list of who gives Fillings test and who do not? Okay, so let's begin writing.
Fillings test defines oxidizable
Okay.
to insert in sugars aldehyde.
Okay, so basically aliphatic aldehydes would give the test. So let's say HCHO, let's say CH3CHO, all these would give the test. Next we have formic acid. That was what I wanted to just check out because even formic acid would give this test. And you have glucose, fructose, galactose, basically all reducing sugars who give you this test. You have alpha hydroxy ketones who give you the test. You also have hemiacetals which give you tests. And let's see who gives negative tests for these. Aromatic aldehydes do not give. And standard ketones they do not give. Non-reducing sugars don't give. Okay. So remember, aliphatic aldehydes give, formic acid gives, reducing sugars gives, alpha hydroxyketones gives, hemiacetals give. Which do not give are aromatic, standard ketones, and non-reducing sugars. Okay, cool. Now let's move on to the next test, which is KISS test. I think you would have heard about this test while you're learning about in biomolecules chapter. Not this. So you have KISS test. So let's see about the reagent first. The reagent is prepared by decolorizing an aqueous solution of para-rose aniline hydrochloride dye and you're gonna add that with sodium sulfide Na2SO3, right? Or you're gonna pass SO2 gas so this makes it decolorized. And how does the test work? When you add aldehyde to the reagent, you're gonna get pink color. So that is how Skiff's test works. So you have to remember the reagent, which is para-rose aniline hydrochloride dye, and you're gonna decolorize it by either passing SO2 gas or Na2SO3. Moving to the last aldehyde test, which is Tollens test. Tollens test. So again, you'll have to know what is a reagent, which is the most important. So in a freshly prepared silver nitrate solution 2%, a few drops of sodium hydroxide solution is added to obtain a dark brown precipitate of silver oxide. Further, ammonium hydroxide is added to a dropwise manner to dissolve the precipitate and obtained solution is termed as Tollens reagent. So if I have to give you the complex of Tollens reagent, let me just write the reaction. I think that makes it easier. So you're going to have RCHO and you're going to add AgNH3 twice plus 2OH minus. So this is basically the Tollens reagent. I want to give it a different color, something like that. So this is Tollens reagent, AgNH3 twice and plus, okay? Remember everything because they might give you AgNH3 4 times and they might give you 2 plus, but always remember it's AgNH3 twice whole plus, okay? And this will give you 2Ag plus 3NH3 plus H2O plus RCOO and H4. And you're gonna get a silver mirror form. Alright? Now let's see who gives and who do not give this test. So let me again ask the internet for more confirmation. Could you tell me who gives Tollens test and who do not give Tollens test? So I can
The
see here
tolerance test,
both
also
at
called the silver mirror test,
okay,
distinguishes
okay, okay. So you can either have aliphatic and aromatic aldehydes to do the test. And to destroy the silver mirror, they usually use dilute HNO3. Okay, let's write according to it. We have aromatic plus aliphatic aldehydes, basically all which give this test. And again, you have formic acid giving you the test. And you have alpha hydroxy ketones giving you the test. And who do not? Ketones and other groups, okay? So remember these three would give aromatic and aliphatic aldehyde, HCOH and alpha hydroxy ketones. and these do not give. Cool. Okay. Moving on to the next next group, which is carboxylic group. So we have carboxyl group. Okay, so in carboxyl group, the first one we have is litmus test. So it's very simple. You like you have blue litmus, if it turns red, that means it's a carboxylic acid. So who gives it is carboxylic group and even phenolic group. Okay. Next you have sodium bisulfide test or bicarbonate, also known as sodium hydrogen carbonate. I think this is very normal. Wherever there is high hydrogen, you kind of put bi there. So the reaction goes like, for an acid, if you add any HCO3, you're gonna get R COONA H2O and CO2. Cool. Alright, so who gives this test? This is a test to also distinguish between carboxylic acids and phenols, because phenols don't give it, and you're gonna get kind of like a brisk effervescence. Okay. Last test in this one, which is ester test. So this is a very sweet test, you know. So when you add RCOOH with R dash OH, which is an alcohol, so you have an carboxylic acid and you have an alcohol, and you're gonna put concentrated H2SO4 and you're gonna heat it. You're gonna get RCOOR dash plus H2O. So this is ester. Okay, you're gonna get an ester formation. This is esterification reaction. So you're gonna have a fruity smell. I don't want to tell it's fruity smell, fruity aroma, okay? Something like that. But so you're gonna get a fruity, sweet smell, okay? Alright, moving on to amino groups. So this is the last group, which is amino group. So in this amino group, you have 3 tests. So you have carbyl amine test, you have solubility test, and you have azodie test. So you have R and H2 with CHCl3 and 3KOH. Remember the reagent, this is basically the reagent. And you're gonna get RNC, which is basically isocyanide. So CHCl3KOH, you're gonna get RNC, which is an isocyanide. So let's see who gives and who do not give this test. So R can be aromatic or it can be an aliphatic group. But secondary or tertiary amine, they do not give this test. Primary amines, they give this test. So let's look into the solubility test. Due to basic nature of amino group, amines react with acids to form salts which are soluble in water and hence they can be used as a test. So you have C6H5NH2 plus HCl. You're going to have C6H5NH3 plus and Cl minus. So this is basically anilinium chloride which is soluble in water. So it's a very simple solubility test. You'll have to remember this is what happens, and this is also the reason why this anilinium group is a meta-directing group, and that's why you have a meta-directed product, which also is among one of the major products when you react with NaNO2. Okay. Moving on to the last test of everything, which is diazotization. Diazotization. Okay. So who gives this? Primary aromatic amines give diazotization, and let's see who is a reagent. Reagent is basically NaNO2 and HCl at 0 degrees Celsius to 5 degrees Celsius. And you also have another reaction which is coupling reaction, and this is one of the important reaction. Why? Because let me show you. So you're gonna take a diazonium salt, which is our usual. And you're gonna add it with something called beta naphthol. Okay. So basically an OH here. One of the most important thing is there is addition on the ortho position. So what next happens is you're gonna get something that looks like this. And this last product is basically beta naphthol which is scarlet red. Okay, so this is beta naphthol azole dye which is scarlet red in color. That is the end of our test. I never knew this was gonna be so many, but let's just look through everything we have. These, we learned about carboxyl group test, we learned about aldehydes and ketone test, and we learned about phenol test and alcoholic. Okay, so I hope you enjoyed it, and I think we've made a great progress in writing them like this. Revision makes it so much more easier. If you want this PDF, please do put it down in the comment box. I'll be sending you guys within few minutes. So I just hope you had a great time together. Bye, guys.